Okay, starting with 10-8 first. So this was the assignment from last night. Now, I already put up all the answers there. So going through them real quick, the first one said a center at the origin, so radius and a radius of 6. Again, those are going in for your formula. So your formula one more time was x minus h squared plus y minus k squared equals r squared. And again, you can either use that r squared at the beginning or the end. It doesn't matter where you put it. On this paper, they put it on the end each time. And then they also simplified the equations each time. So here they had the center at the origin. That means our center is the point 0, 0. So that's our h and our k value. And then our radius, that's our r value. We had to plug those things in. When we plugged in 0, 0, again, it's simplified so that we didn't have it anymore. So it was just x squared and just y squared. And then the 6 squared became 36. On number 2, same idea. You had a center at 0, 0, which is the same thing as the origin. So when you plugged them in, the numbers went away. It was just x squared and y squared equals, the radius was 2, so 2 squared is 4. Number 3, again, plugging them in. Now, again, when you plug them in, since there is a negative in front of the h and negative in front of the k, you have a negative in front of your 4 and a negative in front of the 3 when you plug it in. So even though they're positive, the sign changes when you plug it in. And then the 9 was squared, so 9 squared gave us 81. For number 4, we had 7 and 1. 7 got plugged in for the h, 1 got plugged in for k, 24 got plugged in for r, and again, 24, oh, actually, sorry, did not get plugged in for r. This was our diameter. So first we had to divide it by 2. Our radius was 12, so we had 12 squared, which gave us the 144. On number 5, this one was like the problem that we had done on the board yesterday. They gave us the center, they gave us a point and passes through. So first we have to figure out what our radius is, or we could just get down to r squared, and then we can plug those values back in. So on this one, there's a little extra work to do. So if we start this one off, we're going to plug in, this is h and k for -4 and -1. Then we had passes through -2, 3. So this is going to be my x and y when I plug it in to start off. So I'm going to have -2 minus -4, so that becomes +4 squared, plus, then we had the y value, so 3 minus -1, so that also becomes +1 squared equals r squared. Simplified, -2 and 4 gives us +2. 3 and 1 gives us 4. 2 squared is 4. 4 squared is 16. Add them together, you get 20. Now, if we wanted r by itself, we'd square root it. It didn't ask us to find the radius, so we can just take the 20 and plug it in for r squared, and we don't have to do that extra bit of work. So when we rewrote the equation, we plugged in just the h and k values, left the x and y alone, plugged in the r squared value as 20, and that was our equation. 6, kind of the same exact thing. So again, you had to go through the process of solving. So I'm going to show those steps one more time here. Again, this would be our x and y. This would be our h and our k. So we have 4 minus 5 squared plus 0 minus -2. So that's plus a positive, really, squared equals r squared. 4 minus 5 is -1. -1 squared is just 1. This is 0 plus 2 is 2. 2 squared is 4. 1 plus 4 is 5. Again, that's r squared. We don't have to go any further because on our equation, it calls for r squared. So we could just plug it in like that. So we had x minus 5 squared plus y plus 2 squared equals 5. All right, on number 7, in this one, they gave us a circle. There was a coordinate point. We had to recognize the coordinate point for our center was 3, 2. The radius then is going to be 2, just counting the spaces. Once you knew that information, you plug it into your formula, same as before. So the 3 went in for h, the 2 went in for k, and the 2 went in for R. And again, we had to square that one, so it became 4. On 8, again, same thing, identify the center point. It was at 0, -2. So 0 is my H value, -2 is my K value, R is 3, plug them in. Since H was 0, it just simplified on that side to X squared. I had -2, so it became +2. And then when I plugged in 3, I had to square it, so it became 9. Questions on that top part? On the next set. Yeah. All right. On this part, so they gave us the equation. We had to identify what the center was, what the radius was, and then draw our circle. So we had the point 0, 0 would have been our center point. The square root of 16 gives us 4, so the radius is 4. So again, when you go to graph it, all you had to graph was the center point, graph a point 4 units out from each side for a radius, and then connect those points. Same thing on number 10. We had 1 and 4. That was going to be our center point. Square root of 9 was 3. And make sure when you take those values out to get our center point, using our H and K values, you change the signs. It became a +1 and a +4. Once you had that information, again, graphed it. So +1, +4. We graph that point first. Radius of 3, so went out 3 units in each direction. We applied those 4 points next. And after that, connect the dots, and you have had a circle. All right, the ones on the bottom, 11 and 12, did not do an example like that. I didn't realize that they had that on here. That's actually going to be a little bit harder than we need to do. I'm going to show you real fast what it is. There's another property based on ideas that we've already had. So on number 11, they gave us these 3 points, and you can see they plotted them on the graph here. They had -2, 3. They had 1, 0. And they had 4, 3. Now, the actual way that you would do this, and again, I'm not going to ask you any questions like this on the test. I just want to show it as an example. So I could draw a chord between these. We had a property earlier on that said if a chord was bisected, if you had a perpendicular bisector of a chord, then it was going to be splitting this in half. Is also coming from the center point, so it could be acting as a radius or diameter. Well, same thing here. If we were to find the midpoint of this, which again, I did not expect you guys to do, I shouldn't have assigned this one, and then did perpendicular from there, it would have went through the center point. Same thing here. We went through the center point. Gives us the center of the circle. Again, way too much work. We're not doing that. Moving on. So 11 and 12, if you skipped them, I'm okay with that. All right, going backwards now. So that was from yesterday. That was page 51. The other 2 things that I hadn't gone over yet was page 45 and then the worksheet from Friday. So I want to go back to page 45. Go ahead and take a minute to get that one out, and we can go through that. So on, on here, it said round to nearest 10th if necessary. I believe it is only necessary on like 1 or 2 problems, but you had to find the missing pieces. On this one, I did limit it to a couple of problems. I only told you you needed to do 1 to 3 and 8 and 9. So I told you didn't have to do 4. You didn't have to do 5, you didn't have to do 6, and you didn't have to do 7. So it was only these 5 problems. Now, on the top set, here we had 2 chords intersecting. When we had 2 chords intersecting, then you took the 2 parts from one chord, multiplied them together. So 3 times x, and that'd be equal to the 2 parts of the other chord multiplied together. So 7 times 6. Well, 3 times x is 3x. 7 times 6 is 42. Divide by 3. And x is 14, I believe. Yeah, 14. All right. On 12, we have 6 times x is going to be equal to 9 times 9. 6 times x is equal to 81. Divide by 6. And this one was the one that did not come out to a whole number. That's 13.5. All right. On number 3, again, same idea. 18 times x equals 15 times 12. 18x equals, let's see, that's 30. Yeah, thank you. All right. Divide by 18, and your answer was 10. All right. So those were the top 3. Then you have the bottom 2 to do. On the bottom 2, and so on those bottom 2, we had the tangent and a secant. Both of these use tangent and secant. So the equation here was tangent squared equals exterior times the whole. All right, so this will be our tangent. This is our exterior. And then the whole was these 2 added together. So we had to add 2 and x plus 6. That gave us x plus 8. That will be our whole. So we have tangent squared. So that's 6 squared equals the exterior piece, which was 2, times the whole, which was x plus 8. So 6 squared is 36. Distribute the 2 to both parts. So that's 2x plus 16. Subtract the 16, that leaves us with 20. Divide by 2, and x is 10. On number 9, it was the same thing. So we had the exterior piece was the x value there. Oh, they put another x there. All right, well, this one didn't really work out nice either. I don't know why they like to put so many x's on the outside. Looking at this again, I probably should have given you number 7 instead of number 9, but I'll show it. It does become a quadratic on this one. So that's the exterior. The whole is going to be 2x plus 2. This is our tangent. And since I signed it, I'm going to do the work. Tangent squared equals exterior times the whole. We have 12 squared is 144. Distribute this, we get 2x squared plus 2x. And this is where it became a mess. Let's see. Well, we can go ahead and bring that 144 over to the other side. So we have 0 equals 2x squared plus 2x minus 144. And then we would have had to factor. Well, one good thing here is we have an even number. And again, I'm not going to make you factor on the test. We could have taken out the 2, so divided 2 off of everything. And since we have 0 on the other side, if we just divide 2 off of everything, including the other side, the 2 can just kind of disappear because we'll divide it off. This becomes just x squared. This becomes just x. 144 though, half of that is 72. So then we need factors of 72 that add up to the middle one. So that'd be 9 and 8. So solving this by factoring now, we'd have x plus 9, x minus 8. Set each of those equal to 0 and solve. We've had a -9 and we've had a +8. +8 is the only one that works since we're dealing with length. And that was our answer. So that was a horrible problem to give you. I'm sorry. On number 7, let's go back for a second. Because on number 7, I didn't give this one. This one wouldn't have been so bad because although the x is on the outside, it was on a tangent. So we would have ended up with both an x squared and just an x value. We would have only had the x squared. So if I had done this one, we could have said x squared equals the x there is 8 times the whole. On this one, add those together is 18. Eight times 18 is 144. Square root of both sides, x is 12. Well, that one would have been okay. All right, all the other ones though, the ones in the middle there are definitely quadratics. Just so you remember though, the formula, because they did use 2 secants on each of these. Again, it is set up as x there times the whole is equal to x there times the whole. Again, each time you have a secant, it's x there times the whole. If you had the tangent, you do tangent squared. All right, that was that one. And we also had one other one. Let me save this and clear it off, and then go to one second. Nope, I don't know why that went off the board. Sorry. Okay. All right. Let's go to it's in here somewhere. This one. All right. So on this one, we have more examples where we had 2 tangents, a couple secants, secants and tangents. So this had some better practice on than the last worksheet. But on this one, since we have 2 tangents, we can just set those 2 equal. So on here, we can do E, let me use a different color. For E, we have 3x minus 1, sorry, 11 equals 2x plus 15. Bring the x's to the same side, so subtract 2x. You end up with just 1x. Take 11, add that over to the other side. Actually, let me show it in 2 different steps here. Plus 11, plus 11. So x is equal to 26. Then we had, on the next one, I, we have 4 is the exterior. 3 is an exterior. And then we have the whole is 9. And this whole is 3 plus x. So we have 4 times 9 equals 3 times 3 plus x. Again, exterior times the whole equals exterior times the whole. 4 times 9 is 36. Distribute the 3, that's 9 plus 3x. Subtract off 9, that's 27. Divide off 3, and x is 9. All right, and then we have s, let's see, the tangent is x, so tangent squared equals exterior times the whole. Whole here is 8. So x squared equals 16. Square root both sides. X is 4. So 4. And then we had for C, exterior and the whole on this one. Add 4 to x minus 2, that's x plus 2. 3 is the exterior and the whole is 16. Almost multiplied instead of adding. All right, so I have 16 for the whole. So my equation on this one, 4 times x plus 2 equals 3 times 16. Distribute the 4, that's 4x plus 8 equals 3 times 16, that's 48. Subtract the 8, you get 40. Divide by 4, and x is 10. So C, so 10. Then we had G. All right, on this one, we had 2 chords intersecting, so 2 parts from the same thing. So 3 times x equals 4 times 6. 3x equals 4 times 6 is 24. Divide by 3, and you get 8. So G was 8. Then we had on this one a tangent and a secant. So again, we have an exterior and the whole. So the whole in this case is x plus 4. So when we do this one, we have tangent squared, so 6 squared, equals exterior, which was 4, times the whole, which was x plus 4. So that's 36 equals, distribute the 4, 4x plus 16. Subtract off 16, that's 20. Divide by 4, and x is 5. So L 5. And finally, the last one. We had on here 2 secants. So again, this is the exterior, this is exterior, the whole. So 18 on that whole. This one was x plus 6. Set the equation. 4 times 18 equals 6 times x plus 6. Again, each time is exterior times the whole. 4 times 18 is 72. Distribute the 6, that's 6x plus 36. Subtract 36, you're left with 36. Divide by 6, you get 6. So n is 6. And there was one that repeated. We had 26 was up there twice. And the joke was, what do the complementary angles say to the isosceles triangle? Nice legs. All right. That was the 3 homework assignments that hadn't gone over yet. Any questions? That one? Yes. All right. I'll leave it on the board.